Hello everyone, welcome to the morning session of my vlog. It is day 2 of my vlog. I've studied for 4 hours and I have done one lecture on probability density function, joint probability density function, and done about 50 flashcards. So I've selected this question to show what I've learned, explain it. Let's get started. We are given a joint probability density function of equal to 4xy e minus whole x square plus y square, and the probability density function is in the first quadrant. We have to calculate ex given y. So for that, first we'll have to calculate fy, which is equal to minus infinity to infinity fx comma y dx. So here, as we are differentiating this with respect to x, we are integrating this with respect to x. We can take y outside as constant, y e to the power minus y square, integration 0 to 1, 0 to infinity, as it's in the first quadrant, x e to the power minus x square. Now this can be solved using substitution. Let x square equal to t, 2x dx equal to dt. So we can take 2 from here, then it will become 2y e to the power minus y square equal to 0 to infinity. Limits will stay the same, e to the power minus t dt. 2 to the power y minus e to the power minus y square. So when we integrate it, it will become e to the power minus t divided by minus 1, and it's from infinity to 0. So it will be e to the power minus infinity minus e to the power 0, which will be minus 1, and the minus 1 and minus 1 will cancel out. So ultimately it will be e to the power 2y e to the power minus y square. So that's fx. Now we can calculate fx given y, which can be obtained by dividing the joint probability density function by fy. So that will be 4x y e to the power minus x square plus e to the power minus y square divided by 2y e to the power minus y square. So y square and y square, e to the power minus y square will cancel out. 2x will cancel out with this, so it will be 2x e to the power minus x square. And now for finally for calculating ex given y, we can do it by the formula exy equal to 0 to 1, 0 to infinity, as it's in the first quadrant. 0 to infinity x fx given y dx. So this will become 0 to infinity 2x square e to the power minus x square dx. So this looks very similar to this integral over here, just there's an extra x square. So we can do that, we can do the same thing, and it will become 0 to infinity e to the root t e to the power minus t, as the extra x will become root t, because as you can see from here, dt. Now this looks tough to solve, but this can be solved easily using gamma function. As you know, gamma function is by the formula of gamma function, it will be gamma 3 by 2, because it will be gamma's. I'll write the formula. Integration 0 to infinity e to the power minus x x n minus 1 equal to gamma n. So here n will be 3 by 2, n will be 3 by 2, and that will become 1 by 2, gamma 1 by 2, and we know gamma 1 by 2's value is root pi, so it will be root pi by 2, and that's the answer. Thank you for watching. Hello everyone, this is the evening session of my day 2 vlog. I've studied for 4 hours and I have completed one lecture and revised Python. So in the lecture was about, I learned about this proof, expectation of x given y equal to expectation of x. So I'm going to try to prove it and explain it. So as we know, expectation of x equal to integration minus infinity to infinity x fx, and expectation of gx equal to similarly it's equal to minus infinity to infinity gx fx. And for the expectation of x given y, we know that it's equal to minus infinity to infinity x fx fxy fx given y dx. So we can assume this term to be qy, as it will be free from x because we are differentiating with respect to x and the limits are constant, so it will be free from x and it will be a function of y. Then we find the expectation of qy. It will be equal to, by this formula, it will be equal to minus infinity to infinity qy fx. And now we can expand this into this. It will be minus infinity to infinity integration minus infinity to infinity integration x fx given y dx here will be fy dy, because it's a function of y, it's not a function of x, so that's why there will be fy and fy dy. So as this is a differentiation integration for with respect to dx, we can treat y as constant, so we'll take this fy inside the integration and it will become minus infinity to infinity integration x fxy fy dx. Now as we know, fx given y is multiplied by fy equal to fx comma y, is equal to the joint distribution of fxy. So we can write it as minus infinity to infinity x fx comma y dy dx dy. Now as the limits are constant and we're differentiating with respect to dx and dy, we'll just interchange this. So it will become minus infinity to infinity dy dx. Now as we are differentiating with respect, as we are integrating with respect to y first, we can take x as constant and outside, so it will be fxy dy. Now if we know that this term over here equals to fx, so it will come out to be integration minus infinity to infinity x fx differentiation dx. So, and this is the formula for Ex, as you can see over here. So hence we have proved that Ex given Y is equal to Ex. Thank you for watching.